Good morning, everyone. In this class, I'm going to discuss one of the very important topic and interesting also. We know that automatas are equivalent to regular expressions. So automatas can be converted into regular expressions and regular expressions can also be converted into automata. So there are generally two ways we use to convert an automata into the regular expression, which I have mentioned here. One is using the state elimination method and another is by using the Arden's theorem. So in this session, I'm going to discuss the state elimination method. In next lecture, we'll be talking about Arden's theorem. Okay, so let's start the discussion. Now, let's say if we are having an automata, so we are having an automata like this. Let's say there's a state A and there's a state, let's say B, and there's a state C. You consider, let's say C is final or non-final, that I'm not highlighting which one is final, which one is not. But the important point here is, let's say there's a transaction from A to B and B to C, and I'm considering there is whatever the transaction, there is a regular expression R1 is written and there's a regular expression R2 is there. Now if I want to eliminate or remove this state B, so if I want to remove or eliminate this B state, what regular expression will be written here? So if we eliminate that, it will be looking like A, if A is the, let's say, initial state, right? And there'll be C. C was final, so it will still be final. There's not a change in that. And this transaction will look like, because B has been eliminated, so this transaction will be R1 concatenated with R2. Okay, because there was only single path from A to B. So in case we eliminate like this, then it will look like this. Okay. Now in case on B, if I assume that there was a loop, so if I assume that there is a loop on B, and let's say there is an expression, if I'm writing R3 is there, regular expression. Okay, so in this case, if we eliminate the state B, what we will write, R1 is there. After R1 there are two options, like once we take R2 we cannot go for this path, so logically when I'm traversing from A to B through R1, on B there is R3 I can traverse n number of times, so maybe 0 times or n times. That means R3 to the power star I will consider like cleans closure of R3 and then followed by R2. So this is very easy to understand, not a problem, right? Now if I make it a little complex, let's say, so if we consider that let's say here there is a situation, and I'm cleaning these things also. Let's say we are having B here, that is fine, and I'm traversing from A to B like we were traversing earlier, and let's say we are traversing from B to A as well. Okay, so if this is the scenario, and here I'm assuming there is a regular expression R1 and let's say there is regular expression R2, and from B to C there is a transaction through R3. Okay, so R1, R2, R3 are the regular expressions only. So if we eliminate this state B, if we eliminate this state, how the overall regular expression we will write here. So in case we are eliminating this B, actually indirectly, although we do not mention any loop on A, but there is a loop by traversing R1 and R2, R1, R2, R1, R2. So that means if you eliminate this, we need to put a loop here. We need to put a loop here. So we can put a loop of R1 concatenated with R2 in the sequence. Okay. But when you are eliminating from A to R3, A to C, A to C, there's a path R1 concatenated R3. So there we have to write R1 concatenated with regular expression R3. right? I hope it is clear. Now if we consider, okay, there is a loop on this. So let's say I assume that there is a loop R4. There's a regular expression R4 which is having a loop. Now in this case, if we eliminate this state B, what we need to consider? So if we eliminate this state, then actually when were considering this is a loop R1 R2. Now this thing is not the only thing here. There is R4 also. So this loop will be transformed like R1 then R4 asterisk followed by R2. I hope you can understand this. R1 R4 asterisk followed by R2, right? And this path which we have earlier written like R1 R3, now it is R1 followed by R4 asterisk R3. So this is also very easy to understand, right? Not the challenging one. Now let's say I make it a little more complex it is. So let's say if I clean it, and here also let's say I'm cleaning. So if the situation I'm assuming that there is state B here, but there is a transaction in both the sides. So let's say from here we are having transaction A to B. Similarly, we are having transaction from B to A. Same thing here also I'm creating. So I'm having a transaction B to C and let's say C to A, C to B. Okay. Now if this is the situation, here I'm assuming there is a regular expression R1. This is let's say uh, maybe R2. This is R3 and this is let's say R4. If this is the situation and we are eliminating B from this automata. So in case you eliminate B, what will happen? Now there is a loop. So from A to B and then again you can come back, right? So you consider that there's a loop of R1, R4. So if I'm considering there's a loop, the loop is of R1 concatenated with R4 here. Similarly on C, because the B was having a kind of loop. So from C, if I follow this R3 regular expression, from B I can go back. So R3, R2, we need to consider there was a loop that should be existing if we eliminate any of these state from the automata, because we are trying to create equivalent regular expression, right? Now what about the path? So there were path A to C, there is a path R1 concatenated with R2, and from C to A there is a path R3 concatenated with R4. So there is another path from this to this like this, but this path is R3 concatenated with R4. So I hope this is also clear. It should not be challenging. Now if I assume there is a loop on state B, so if I assume there is a loop on state B, and let's say I'm writing here R5. Okay, so if there is a loop here, how we will change these things? So by making a little changes, all these things you can modify. Okay, now so what is happening in case of this R1 R4 loop? There is R1 R5 star and then followed by R4. So you are going by R1, there's a loop of R5, you are eliminating this state B, right? So this loop will give you R5 asterisk and then you are returning by R4. Now if you are eliminating this, same thing will happen, R3 R3 and then R5 asterisk followed by R2. Here R3 R5 asterisk followed by R2. So there's a loop, and this path R1 R5 asterisk followed by R2, you reach to C, and from C to A R3 R5 asterisk Sorry, followed by R4, right? So this is also easy. Okay, now if we consider one more scenario, if you are having loop here also, if you are having loop here also, so if I have, let's say already there is a loop, I consider uh, there is a loop, let's say there was R6, and let's say there was also a loop R7, then what will happen? So if it was the loop, after elimination of B, this loop should exist, and whatever the new loop by removing of B should be there, that will also be there. So that means along with this regular expression, there should be R6 or this particular loop R1, R5, S3. Similarly here, because R7 need to be there, so there will be R7 or this loop will also be there by removing B. Easy, right? Okay, so that is there. Now if we make a little more complex thing, so if I'm assuming that a little difficult diagram, not really difficult, but some totally different thing. So if there are three states, let's say, because there may be a number of states, so I'm assuming that, let's say B is here, you are having B state is here, and these regular expressions I'm just removing. Okay, so you are having path from A to C and C to A. Okay, we are having path like this. Okay, right, now we are having path from C to B and B to C. Same thing, we are having path from A to B and then B to A. Okay, so let's say we are having this path. Okay, and then we are having another path from B to A, so that is the path. Okay, and to make it more complex, we apply, there's a loop on every state, right? So let's say path, I'm saying this is R1, and let's say you are reverting with R2, this is R3, R4, this is R5, R6, R7, R8, and R9. These all are regular expressions. So if you start eliminating, this, okay, so what will happen if I take this particular, okay, better to have it here. Now draw a new diagram. So you can decide what you want to eliminate. Possibly we are trying to eliminate B. Okay, so because we want initial and final to be there in the diagram, and rest of the states we try to eliminate. Okay, so finally when this method you adapt, you try to convert a regular and finite automata to regular expression. The intention is finally there should be only two states left in the diagram. One is initial, another is final, nothing else. Okay, so we are intended to eliminate B. So if we are eliminating B, then what will happen? How we can eliminate in this situation? So let's consider that we are having, let's say this is A and this is C. So that we are having, if C was the final, it is still final. A was the initial, it is still initial, no problem. Now there'll be only so if there was some loop, the loops will be existing. And if there was a path from A to C and C to A, the path will also exist. So we can draw A to C. There was earlier a path existing, so it will be there, and C to A also will be path. But the regular expression on this path will be modified. So let's look at the regular expression. Now, when we are considering R7 was there, so R7 will still be there. There was R8, so R8 will still be there. There will not be any problem. So these two were there, it will still be there. Now when you eliminate this, and here actually R1 was possible, so R1 is still there, and there was R2 there, so R2 is still there, no problem. But along with this, there'll be something else, okay? So along with this, when we want to traverse, actually indirectly there's another path from A to C. The path is, you can traverse through R3, then there is R9, and then R6. So along with R1, there is another path existing from A to C, that is R3, followed by R9 cleans closure or star, followed by R6. I hope you are getting this. Similarly, C to A, there were another path existing, C to A. R2 was there, but indirectly you can follow R5, R9 star, R4. So you can follow R5, R9 asterisk here because there's a loop, and then R4, so that you can follow. What about these loops? When you are removing this B, actually indirectly there is a loop. So you can traverse this loop R3, R9 star, R4, R3, R9 asterisk, R4, R3, R9 asterisk, R4. So you can write this R3, R9 asterisk, R4 here. I hope you can understand this. Similarly on C, along with R8, you write this thing R5, R9 asterisk, R6, R5, R9 asterisk, R6. So along with this, we can write R5, R9 asterisk, R6, right? So this is the updated automata. This is the updated automata which we have. Okay, I hope you are getting it. So now you may ask that how finally we will get a single regular expression. So what exactly we try to do? In the previous class, we have already seen that any of the regular expression, let's say we are having an R1, and if we assume that there is an epsilon, or we assume that let's say this side also is an epsilon, then it will obviously will give you R1 only. So if finally we want to convert any of the automata into a regular expression, what we assume that we take a new initial state we can take. So let's say I assume that, okay, no, let's say A is not the final one. Let's say there is some state, epsilon state or something state, which I am assuming that this is the initial state. And we can reach from this state to the initial state of the automata by traversing null. Okay. Similarly, we do not assume that C was the final one. We can introduce one new state. So let's say F or any state. And here we are traversing through. So whatever the regular expression was running here, overall thing, if I assume that this thing was a regular expression, this thing was whatever this thing was, it was a regular expression, let's say from here to here R. And in this R or R1, you are concatenating both side epsilon. I hope you are getting. So now what we need to do is we need to eliminate this. We need to eliminate this as well. Once we eliminate all, there will be single regular expression. So in a automata, when you have eliminated all the states excepting initial and final, whatever you will get here in the middle, that will be considered as your final regular expression. Okay. So we can take some examples. I hope till now you must be clear about how we can convert an automata to a regular expression. So let me quickly take some examples. the examples like, so if we have an automata, so let's say there's a state A and there's a state, let's say, or I may consider, let's say, state 1 or a state 2 or a state 3, like this. And you may assume that any of these three, any one is the final one. So let's say this, you assume that this is the final one. Okay, to make it more complex. Now the transactions you can write. So you are traversing from this state to this state. Then you are traversing this to this. Let's say again you are traversing back. Fine. Now if we assume that the alphabet is A comma B, so if alphabet is A comma B, you may put something. So let's say I'm putting a loop of B here, that it is traversing through A here. There's a loop of B here, it is traversing through A here, and let's say it is going by B here. I'm not considering, you can apply a loop here also for A, so it's your choice. So let's say this is the automata. Now if you want to convert this thing, what exactly we try to do is, we consider, okay, there is one initial, one final, in between everything you are just going to convert into an automata. Okay, so we want only one thing in between, one link, nothing else, and whatever you will get there, that will be considered as a regular expression. Okay, so what I'm trying to say here is, don't consider this as a final one. So the very first thing, I remove this, I do not consider this as final. I write some new final state. So let's say I assume that there is a new final state. That final state can be named as, let's say, 4. So this is the final state, obviously by traversing null. And if I assume that there is an initial state, so let's say 0 state, I am assuming this is my initial, so I can have here epsilon. So there should not be any problem, these are newly states, so let me highlight in one new color. Okay, so this is 4 and this is 0, which additionally I am adding with the lambda transition. Okay, so please don't get confused. Now what we need to do is, one by one we have to remove everything. So let's say if you are removing this, so the very first thing, let's say you are removing 2, this state you are trying to remove. So once you remove it, you will have another path from 1 to 3, because this path was leading you from 1 to 3. So I am drawing one path in different color, let's say. So one path from 1 to 3, it has been added. But on this path, we need to maintain whatever we were getting from there earlier. So it was A, B star, A. So A, B asterisk, A we were getting. And now we can eliminate this particular path. Okay. Right. So this has been eliminated. Now next, if you want to eliminate this 3, so now we want to eliminate this state number 3. So if we want to eliminate this, there is a loop of this. Okay, and one is also having a loop of B. So along with B, by putting or symbol or plus symbol, we need to write this particular. So let's say if I write here by adding something, so I'm putting or here, and I'm writing A B asterisk A concatenated with B. So I'm saying A B asterisk A B. By removing this 3 state, I'll get a loop here, and there was another loop, so I will get this thing. So I'm eliminating this. I hope it is very easy to understand, right? Now I want only single path from this to this, so I redraw it, let's say. So I'm drawing 0 state, and there is, let's say, state number 4, and 4 is my final one. Now I'm drawing single path from 0 to 4 after eliminating everything. Everything means I'm going to eliminate this state number 1 also. So once I eliminate this state number 1 as well, what I will get? I'm going to get here, let's say, epsilon concatenated with what is here. Here it is, you can say B or this particular thing, A B asterisk A B or epsilon. That means this epsilon, not exactly epsilon, not or, actually concatenated. So this thing you are saying epsilon. That means these epsilons are nothing. You can concatenate epsilon with anything in any manner, you will get that thing. So that means finally that automata has been converted into B or AB asterisk AB. So this will be the final answer of the question which we have solved. So I hope this lecture will help you to convert an automata into a regular expression. In next class, I'll be elaborating how we can convert an automata into a regular expression with the help of Arden's theorem. So this is sufficient for the class. Thank you everybody for connecting. See you. If you are liking all my lectures, please share with your friends. Okay, and subscribe it. Thank you everybody.